Based on the circuit in part A, we found that the current is the same through every resistor, but the voltage is divided according to the resistance values. When we increase the supply voltage, the current increase proportionally, and when we remove more resistor, the entire circuit become open, so no current flow. This helps us compare with the combined circuit in part C later.
For the parallel circuit in part P, we observe that the voltage across each branch remain the same. The total current increase when more branches are added. Also remove one resistor only affect that branch, but the rest of the circuit still works. These behavior are different from the series part, and they are useful when understanding the combined circuit.
Now, I will present the results and explanations for part C, which is the combined series parallel circuit shown in figure 3. First, we build the circuit in Tinkercad according to the diagram. The circuit consists of a 12-volt supply followed by a 10-ohm resistor in series. After that, the circuit splits into two parallel branches with 20 ohms and 40 ohms resistors. These two branches combine again and then pass through a 5 ohm resistor. Finally, the currents flow through a 15 ohm resistor and return to the power supply. When we measure the voltage across each resistor, we found that the series resistors share the total 12-volt supply according to their resistance values. The parallel resistors 20 ohms and 40 ohms both had the same voltage across them, which measures the rule for parallel circuits. This behavior follows Ohm's law V equals to IR because the voltage drop across each resistor depends on its resistance and the current flowing through it. Next, when we're measuring the current, we observe that the same current flowing through the 10, 5, 15 ohm resistors because they are all in series. At the parallel junctions, the current split into two parts. The 20 ohm branch carry a higher current than the 40 ohm branch. Then, when the branches recombine, the total current returns to the value we measured in the series section. This behavior is explained by Kirchhoff's current law, which states that the sum of currents entering a node equals to the sum of currents leaving the node. And here is the table result shown for each resistor's voltage and currents at normal operation. Next on, we will be looking at disconnecting each resistor one at a time. When a series resistor such as the 10 or 15 ohm resistors was disconnected, the whole circuit became open. No current will flow anywhere, and all voltage readings drop to zero. This confirms that series elements completely control the continuity of the circuit. However, when we disconnect one of the parallel resistor, only that branch stops conducting. The other branch still have voltage across it and still carry current. The total current decreased, but the circuit continue working. This behavior measures both KCL and the rule that each parallel branch is independent. Also, here is the table overview shown on the calculations how we get the actual value by applying the laws and formulas. Now, let's look on this part. Short circuit on each resistor. When a series resistor was bypassed, the total resistance of the circuit decreased. As a result, the current in the entire circuit increased significantly. This is expected because with a lower total resistance, Ohm's law predicts a higher current for the same voltage. Then, when we short circuit on a parallel resistor, that branch became a very low resistance path. Most of the current flow through the short circuit, while the other branch carry almost no current. This demonstrates how dangerous short circuits can be in real circuits because current concentrates in the lowest resistance path. Lastly, as you can see on the table comparison results shown on each different resistor, almost every resistor will get zero voltage when it is on short circuit. However, for the other resistor, they might be increased or decreased to a very small value. In conclusion, we can see that by using the electrical laws, These results are all matches the theory. First, Ohm's law explains voltage drops and current distribution through individual resistors. Second, KVL law is observed because the sum of all voltage drops in the series loop equals the 12-volt supply. And the third one, KCL law is observed at the parallel junction where currents split and then combine again. Overall, this combined series parallel circuit clearly demonstrates how voltage, current, and resistance behave differently depending on the circuit configuration. The measurements from Tinkercad match perfectly with the theoretical laws. That's all for our circuit constructions and measurements by using Tinkercad. Thank you.